So welcome into our first IPv6 lab. In this lab, we're going to implement IPv6 addressing on our Cisco routers. We're going to verify that we can ping each of the routers on the local segments and validate that all of the addresses are what we expect them to be. Now, I've set up a very simple lab here, and I have used the site local address generator at ultratools.com to come up with an actual valid site local prefix and subnet. And you'll notice the only difference is really this last byte here, 1, 2, and 3. And unlike IPv4, I don't have to actually say, well, this is going to be the 1 and the 2 and so on and so forth. You can if you so desire. In this case, we won't, just because it's not actually required for this particular lab. When we assign the addresses, you'll see where you can actually specify the interface ID specifically instead of letting the router pick it, but we won't do that. We'll let everything stay as automatic as it can get at this level of IPv6. Now, I've not included this as part of the work file simply because this is just 4 routers I dragged onto the topology and linked together using Ethernet links. There's no configuration whatsoever on any of these routers, so that you can see start to finish that I started with nothing and I ended up with a fully routed IPv6 network by the time we're done. So first we'll start over here on Alternia, just to show there's nothing up my sleeve. Show IP route. No connected routes, no local routes, no static routes, no anything on this guy. Show IP interface brief. They're all unassigned, and in fact, they're all administratively down just because of the way GNS3 brings it up. And in fact, since we are using IPv6 for this lab, we'll do show IPv6 interface brief. We see that the addresses are unassigned and administratively down on that as well. So as you can see, we're starting from scratch. So the first thing we have to do once we go into config mode is we have to actually enable IPv6 routing. Again, most modern Cisco IOSs come with IPv6 support compiled in if you pick the correct image, but it's not enabled by default because, again, not many organizations use IPv6 routing. Now, if you don't turn on IPv6 routing, you can still assign addresses to the interfaces and you can still ping, but it acts like a host instead of a router, which is good if you're in a lab and you just want to throw a host on there to see how well it works without consuming all the routing updates. In this case, we'll say IPv6, and the command we're going to enter is unicast routing. Congratulations, we've implemented IPv6 routing. Everyone go home now. Of course, I'm kidding. There's a little more to it than that. Let's start off by configuring the IPv6 address on Alternia. Now let's look over here in GNS3 and see which interface connects to Prospit. So Alternia Fast Ethernet 00 connects to Prospit Fast Ethernet 00. So we'll go into interface Fast Ethernet 0/0. We'll do IPv6 address. And again, we can specify the link local address, or we can specify an address with an IPv6 prefix. In this case, I'm going to go out here and double-click this just so I can copy that off, like so, and that way I don't have to type all that in all the time. So IPv6 address, and we'll right-click to paste that in there like so. If we hit question mark, we now have the address of leaving everything as all zeros, which again is not recommended, just like you wouldn't leave the IP address all zeros, or we can say use EUI64 interface identifier. In this case, we'll say use the EUI64 identifier just because we don't want to specify an actual interface address manually. Now, this is where you would specify it manually if you were so inclined. We're not going to, so we'll do that. We'll also do no shut. And so now this interface is up. Join us in the next video where we configure the next router and make sure that we can ping back and forth between the two.